operators, partially just the syntax, but also the logic associated with them. But a big part of this topic is logical indexing, which is a way to find conditions inside of an array all at once, looking at the entire vector at once. And this sort of logical indexing, it's like the one we just did. So if you have an array and you put in the condition, which elements are less than or equal to 4, and set that equal to y, then this will have ones and zeros, one where it's true, 0 where it's not, and then you can input that logical array back into the original and it will print out just the values where it's true. So this is really useful, and then using it in conjunction with the find command, which gives you element values, can really do a lot as far as logic is concerned and what you need to do. We also introduced if statements in this topic, and you did them a little bit in your pre-lab. You're going to need to use them for your lab 5, but it's a nice thing to introduce during the rest of the logic topic, because if statements are basically just checks that allow you to only execute a section of code if something is true. So they're used in the cases where you may need to execute code depending on certain conditions. So you just put the code inside the if statement, but I'm going to show you more of that today. The last thing that was a big check-in in this topic is the equal sign. So this is a time where you can really reflect on what an equal sign does in MATLAB. So one equal sign is exclusively reserved for defining variables. 2 equal signs are used for relational equality. Okay, so you have to keep those separated. Any questions on any of this? Yeah.
It's not on this, but you were talking about how we don't have lab next week.
Mm-hmm.
So if we didn't finish the lab last week, but we want to finish it and get it checked off, should we just put it into D2L and then get it checked off 2 weeks from now?
Yeah, so if you look at the schedule, the due date for lab 4 is, the next lab that we have. Any other questions? Okay. So my tips and tricks for this one are a little bit of a repeated thing, but remember that there's 2 reasons that you can get the matrix dimensions must agree error. So I'm showing you an example of both. So the first example of that error is because I'm using the multiplication symbol, which is reserved for a matrix multiplication, which we've talked about, which would be like if you want to do the row times the column, the row times the next column, which you use for matrix algebra. So there's an error because the dimensions don't work for matrix algebra in this case. It would have to be a row times a column if you wanted to do it that way. So that's where you get that error. The second is the exact same message, pretty much, but the problem here is that the dot operator is used, but the 2 arrays that you're multiplying by each other are not the same size. So when you get to the last element of B, there's nothing to multiply that by in A. Okay, so those are 2 errors that you see a lot. One is basically you forgot the dot operator and you were doing everything else right. The second one is that something about your arrays are not balanced. So anytime you've entered in arrays by yourself, or maybe I don't actually know how this happens so much, but they're just not the same size. The last one is just a reminder. I've said this so many times, but make sure that you're typing now clear all, close all at the top of every file, especially at the top of quiz files. Yeah.
So would it be clear all because that's what I've been writing. Is that the correct syntax, or should I be using something else?
CLC is actually different than clear all, but you can use that as well. Clear all clears your variables in your workspace, and CLC erases your command window.
Okay.
Does CLC also erase your command window? Yeah, see, it doesn't remove the variables from your workspace. It just clears out your command window. So you can type all. I don't like to type CLC in my files. I just, when I want to clear up my command window, I just do it manually in the command window. Any other questions? So today I'm going to be doing the entire lecture in an M file because I'm going to be showing you so many examples today. So I'm going to write the notes inside the file as comments. So we're doing 3 different things today. We're going to be doing some examples of if statements. I feel like if statements are probably the most intuitive thing that people just get right away. It's just a check, and so I'm going to show you a couple examples. The next thing that I'm going to introduce are the 2 control flow loops that we're going to be using in pretty much every single file that we write from here on out. So there will be a loop in every single thing that you write forever, the rest of your life probably. And loops are so good. This section is so important, and loops, there's something very intrinsically not visual about a loop. Okay, so for some reason it seems to confuse people. So I am going to say so many important things today. Like every word that I'm going to say is basically going to be totally critical. I'm going to really kill this lecture. So like listen to what I'm saying, okay? I swear. Or you can come back and watch this video for all of you on video right now. I'm recording this. And just re-listen to my beautiful words. So let's start with if statements. So I gave a quick example last time using a prompted input because without loops, it's kind of hard to do anything with an if statement. So I'm just going to prompt the user for a response. So again, I'm going to do the same thing. I'm going to say, I'm going to have the user put in the addition 2 plus 3. I'm going to have them answer what that addition is. So I think what I showed you last time is just an if statement. So if the user puts in a value of 5, then the user is going to be correct, right? They put in the right answer. So this is an example of I only want to tell the user correct if they responded correctly, right? So the if statement is required to give an adequate response to the user. So if I run this code here, I'm going to be running a lot. And so let me see so we can do both at once. So the prompted input goes up onto the screen. The user puts in the response. And if the user puts in 5, then they get the message correct. If they put anything else, they get no response because there's no other commands or things to execute in this code, right? So if you do want an alternative response, if they put in an incorrect answer, then you can add an else statement. So if they put anything else other than 5, you can put in a different display statement to provide them some feedback on their progress. You have a question?
So you want to do multiple statements, say like x equals 4 or x equals 3, and you want to display close. How would you write that in this?
So that would, you mean requiring multiple inputs from the user?
Yeah.
That's what a while loop does, so we'll do that at the end. But it's basically an if statement that gets repeatedly checked until the condition is met. That's what a while loop does. So let's hold off on that and come back to it. So this is an if else. Now let's say that you want to be a little bit more useful with your feedback. So you want to check multiple things, not just if they got the answer right. So let's say you wanted to check if the user maybe guessed a number that was either too high or too low. So if they put in something less than 5, then you could say guess higher. And then if they put something that was greater than 5, you could say guess lower. In this particular file that I'm running, the user will have to rerun the file every time to guess again. And in order to avoid that, we could use a while loop later. So if they put in something too low, the feedback is guess higher. If they put in something too high, the feedback is guess lower. So that's the basics between a single if statement, an if-else statement, and then an if-else-if statement. Question in the back? That would go to none of these would be correct, so nothing would get executed, but I can show you. I didn't actually know that's what an else if did. I thought it had to satisfy that condition. Oh, do you know what it is? Oh no, that got updated. Oh, that's right. It converts the string, thank you. It converts the string to its equivalent numeric number. The only way it would change is if I made the input a string. Then I think it would do nothing. It still converts it because it's using the relational condition. So what it's doing is it's converting that string into its equivalent number, and then it's using that number as its comparison. Any other questions?
So what's the difference between else if and like multiple ifs?
So else ifs will not check if the first one is true. It doesn't check the next one. So it leaves the loop if the next one is true. If you do multiple if statements that are separated, it'll check all of them. So it just depends on the logic that is needed for what you're writing, if there are multiple options or not. That's the same thing that goes with like nested if statements, whether they need to be nested and checked in that way or not. Any other questions about if statements? Okay. So let's look at our first loop. This is a monumental event if you have never programmed before. I feel blessed to be providing this information to you. So a for loop is, the definition is, it's a construction that basically runs a set of commands a predetermined amount of time. So there's a lot of ways to use for loops, and so I'm going to show you one that is the most basic. It's actually kind of like a classic programming first loop. It's really dumb, but it's honestly what you do. So the way that you set up a for loop is everything is going to have a wrapper in loops and in if statements. So with the if statement, there's always going to be an end for every if, right? And that's how the for loop works. You type in for, and then when you're done with the loop, you type in end, and anything in between is inside the for loop. It's inside the loop. So those would be the commands that get executed. So in general, any command in here the way that I've written this, for every element in the array next to the for statement, the commands inside the loop will get executed that many times. So right now I've set up an array that has 10 elements. So that means anything inside this loop will get executed 10 times. So typically you write a loop because you want to repeat a bunch of things that are going to be slightly different each time, and you don't want to retype it. But what I'm going to show you as your first example is I'm just going to put in a display statement, because I think this just shows you how the loop works. So I'm going to comment this out because I don't want to have any of those input prompts, and I'm just going to run the for loop. So what this says is repeat everything between the for and end however many elements are in the array that you've specified. And I think the most confusing part about MATLAB syntax is that a lot of people, instead of writing this, they just want to write something like n equals 10 and just say run this 10 times. And that makes more sense to most people, but that's not the way MATLAB syntax works. It needs an array and it will run for every element in the array. So some programming languages do use this syntax, but since MATLAB is a matrix laboratory, everything has this like matrix or array kind of aspect to it. So let's run this. I mean, that was beautiful, but that's all it does really. So if I change the loop to only have 5 elements, it will only execute the command 5 times. If I have it be a lot, it'll just execute it that many times. So it's just repeating everything in the loop, however many elements there are. So for example, one thing that you can do is inside the loop, you can use what we call the index of the array. So typically we use I for this, however, this can be any variable. That's kind of what's also confusing. So if this is if programming is really new to you, just always use the index I for your for loop, and then just always set your array up to integer values of an array. So if you put I and display it in there, you can see that as the loop runs, I has a different value. The first time the loop runs, I has a value 1. The second time it runs, it has a value of 2. So this allows you to basically do different things with that I value every time you run it. So that's the basics of the for loop. So let's just look at a couple different ways that we can use for loops. So one way that we use for loops is to define an array. So let's say that you wanted to define the following array. And I'm going to do all really small arrays so that you can see what they're doing. So let's say you wanted to have the array V, and it's going to have even integer values, and you want to define each element individually one at a time inside a loop. So I'm going to show you 3 different ways to define this array. Obviously, if you were going to define this array, you would define it like this. This is the easiest way to define a 3-element array, but imagine that this array is much longer. So method 1 is to use a loop. So I know that the loop is going to have, or I know that the array is going to have 3 elements. So I'm going to run the loop 3 times. So I'm going to start at 1 and end at 3, and I'm going to use the index I. I'm going to determine how to define each element of the array based off of the index of the array. So if I equals 1, the first element is 2. If I equals 2, the second element is 4. If I equals 3, the third element is 6. So the pattern for that would be 2 times I. Does everyone agree on that? And then the index I gets used as the element that you're calling out in the array. So when I equals 1, we're going to define the first element of the array V, and we're going to define it as 2 times 1. When I equals 2, we're going to define the second element of V, and it's going to be defined as 2 times 2. And when I equals 3, we're going to define the third element of V, and it's going to equal 3 times 2. And that's what the loop does. It just does that calculation 3 times for you. So what I'm going to do is run this and unsuppress it so you can see it build the array. So the first time the loop runs, it defines the first element 2. The second time it adds on the second element 4. And then the third time it adds on the third element 6. Okay? So
What happens when you run it stressed? Does it just display your
there'll be nothing. Yeah. Oftentimes when we're going to run loops, I'm going to show you them unsuppressed so you can see how it works. So this is called using a loop without pre-allocating. And I think I've already talked about pre-allocating in a previous lecture, and loops is where pre-allocating really matters. So this is what I would call a very bad way to define an array with a loop, because what this is doing is MATLAB is finding new memory every time an element is added to the array. So when there's one element in the array, it goes and finds a spot in memory. Then when there's a second element added on, it goes finds a new spot in memory and it keeps that old one still filled. Then when it does the third one, finds another spot. So it's filling up memory like n factorial, right? Like it's not exactly n factorial, but do you know what I mean? It's like it fills up memory really fast. So if you're doing problems with arrays that have 1,000,000 points, which is that's very common in engineering, there's not enough memory to do that, so it won't even allow you. So instead, we're going to be using method 2, which is still defining with a loop, but with pre-allocation. So you're going to define the loop the exact same way, but instead of building the array from nothing, you pre-allocate the size of the array before you start filling it in. And we typically use the zeros or ones function to make an array that's filled with zeros, that's the proper size, and then this loop just fills in each one. So what I'm going to do is I'm going to run it unsuppressed, and what you'll see is that as the loop runs, it has zeros as placeholders, and it just replaces the zeros with the numbers. And this can speed up your code immensely when you start running big problems. So that's why we're going to use proper programming practice and pre-allocate our arrays all the time before we use them. Did you have a question in the back? That's the default if you don't include the second dimension. It's always going to be a row. Any other questions?
This might be a little bit more with if loop or with if statements, but in a lot of programming languages, if you have an if statement that you just give a number that isn't 0, some programming languages will count that as true. Does MATLAB do that?
I don't think so. Okay. I think it would probably give an error. So let's say you had this logical statement x, and then you replaced one of them with like a number. Oh, it does, yeah. I didn't know that. Yeah. Any other questions? Okay. So that's method 2, the pre-allocation. So the moral of the story is just pre-allocate everything. Okay, so always pre-allocate before you fill. And hopefully that made sense why. The last way that you can define the same array is what I call vectorized. And we're going to always be talking about these like vectorized forms versus loop forms. So to do the exact same thing without a loop, you don't need to pre-allocate because you're building the whole thing at once. You can just use shorthand colon operators. So if there's a pattern that's easy to define in this way that doesn't require a loop or an equation, then you do want to use vector notation to do it. So what this does, and this is what we've already done in previous topics, is it starts an array at 2, ends it at 6 with a step size of 2. So all three of those things are doing the same thing 3 different ways. Method 1 is a bad method that's allowed that you shouldn't do, and method 2 and 3 are both good methods. Okay, a lot of times what we're going to be using loops for is to do complicated calculations that you won't be able to do using vectorized notation. So let's say that we have 2 arrays. I'm going to define one as P and 1 as Q. So I'm just making up some data that fills those two arrays. And let's say that you wanted to multiply the two together. So we're going to skip method 1 because I already told you it's a bad one. And we're just going to do method 2, which is loops with pre-allocating. So this is the most common way that you'll write a loop. So you need to repeat a calculation how many times? If you want to multiply all the elements of P by all the elements of Q. How many calculations is that? It's going to be 100 calculations. So you need to repeat a calculation 100 times. So one thing you can do is just hard code in that you want to run this loop 100 times. That's what we just did in the last example. But an easier way that avoids you having to do the calculation yourself is to just use the length function and just say, I want to do this calculation for every element in P. So the length of P will be 100. So most of our loops are going to be written this way, where you start at 1 and you end at the length of the array that you're looking at. And I'm going to just put in the equation. So for every element, I'm going to have a new calculation, and I'm going to save it to a new variable m. And then I'm just going to multiply the equivalent element in the P and Q arrays. So when I equals 1, it's going to take element 1 of P and multiply it by element 1 of Q and place it in element 1 of M. So what do I need to do before I do this calculation? I need to pre-allocate it. So I'm just going to fill the M array with zeros that are the same size as one of the two calculated arrays that you're using. Someone else said the dot. Do we need the dot here? We don't need the dot because every time this loop runs, it's pulling out an individual element. So the equivalent for this is method 3, vectorized. So this same thing, and this is the way we've been doing it, is we're just doing all the calculations, all 100 at once with that dot operator, and that's what that does. So we would never really need a for loop in order to do this calculation, right? It makes much more sense to use the dot operator. But I encourage you to program all of these whichever way makes the most sense for you, whether you think vectorized makes more sense or loops make more sense, so that you can really understand what your code is doing. But the way that we're going to be using loops is not just calculations like this. They're going to be more complicated, you know, that are going to require generalizing some sort of pattern.
So with method 2, if P was a different length than Q, it wouldn't come up with an error. It would still calculate it as you would want it to. But with method 3, if they were different lengths, would it come up with an error?
It would come up with an error if P was longer than Q, but if Q was longer than P, it would be okay. That's true. That would just be what we call like a logical error. It just like you'd set it up wrong. It wouldn't cause a MATLAB error. Any other questions about those? Okay, so now let's look at the last loop, a while loop. So the definition of a for loop is it's a loop that you write when you know how many times you want to repeat something, okay? So it's really a useful tool, but it can almost exclusively be replaced by other things, but it's still a nice feature to develop logic. A while loop, on the other hand, is very necessary. So a while loop repeats the commands inside of the loop until a condition is met. So basically, you use while loops when you need to repeat something a bunch of times, but you don't know how many times you need to repeat it. So the way that a while loop works is the wrapper that turns blue is while and end. And then inside, next to the while loop, instead of putting an array that tells you how many times to run the loop, you put in a condition. So let's do that same example that we were doing before, the input prompt. I'll just go up and copy it. So let's say that we were going to do the same thing where we are going to ask the user what 2 plus 3 is, but this time we want to continue to ask them until they get it right. So we want to keep checking it. So the condition on the while loop is you want to keep asking as long as they didn't put in the right answer. And that's the most confusing part about while loops, is you need to kind of opposite what you're wanting. So usually you want x to be 5. So the condition on the while loop is keep doing the commands until x isn't 5. And then once it isn't 5, stop the while loop. So let's look at what that means. So we're going to ask the user to input x, and we're going to keep asking them until they put in the right answer. So we can add some if statements in the while loop to encourage them to guess a better answer. But for now, let's just keep it simple. And let's keep asking them this question until they put in 5. Does anyone know what, just from looking at this set of commands, does anyone see a problem with it? It doesn't know where to start. So let me comment out what I've done again. If I run it just like this, I'm going to get an error message that says it doesn't know what x is, because the first command it executes is line 61, and it says, is x not equal to 5? But we've never told it a value of 5. So with conditions in while statements, you always have to start the condition off at something. You could either just set it to 0 just so the loop runs, or the alternative is to ask the question before the loop so that you get an initial guess to start the loop, and then ask again if necessary inside the loop. I always do it this way, which is just set x to a value that makes the loop go. So we're going to run it. X is 0, so it checks. Is x not equal to 5? True, right? X is not equal to 5. It's going to run the while loop. I'm going to put in 4. Now x has a value of 4, so it still is not equal to 5. So it's going to ask me again to put in another value. And then when I put in 5, it's going to leave the while loop, and now there's no more code to execute. So that's the idea behind a while loop. You typically set it up when you don't know something about how many times something needs to happen. So it's a really good example because you have no idea what a user is going to put in for this number, right? You don't know how many times it's going to take to get them to put in the right. So anytime you're filling out like a form online, or you're putting in something and a password checker, you know, like a password checker, that's the kind of thing it's doing. It's just a conditional check to make sure it's meeting some conditions. So let's now use a while loop to replace a for loop. So for loops are basically not needed because while loops can do everything a for loop can do, but it's not, the opposite isn't true. So let's redefine that v equals 2, 4, 6. Let's redefine this array with using a while loop. So the way a while loop will work is you create the wrapper, but now instead of putting the array I equals 1 colon 3, which is not a condition, that's an array that would tell a for loop how many runs, you instead put in a condition. So you want the loop to run as long as I is less than or equal to 3, because I want it to run 3 times. You're going to start I off at 1, and then you're going to advance I in the loop each time the loop runs. So what this will do is this structure I just wrote basically repeats the same thing as for I equals 1 colon 3. It does the exact same thing. So let me first just run it with nothing in it, so you can see that it's the same. So all I've done so far is I've just printed I, so you can see that every time the loop runs, which is 3 times, I has the value 1, 2, or 3. So now, if you want to define an array or a calculation or anything that you need to do, you can do the exact same thing that you did with the for loop. So this will end with a v that's 2, 4, 6, just like the for loop did. Okay, the next thing I wanted to does anyone have any questions about the while loop structure? So for loops run a set amount of time. The only thing that you need to be careful about is the syntax requires an array. The while loop just requires a condition that you continue to run the loop at until the condition is basically false.
So your I equals I plus 1 is just changing your I variable to the next until that condition is met.
Yeah, so this is something called a counter in programming. It's setting a value to 1 and then increasing that variable by 1 every time the loop runs. So anytime you use a while loop in your code, you have to have a counter in order to know what loop iteration count you're at, because there's no intrinsic one like with the for loop. The for loop keeps track of it through that array, and a while loop doesn't have that. So most while loops will just have this counter. Yeah.
Is that pre-allocated v yet?
No, that's good. So we should have pre-allocated v. Thank you so much for being here. Any other questions?
Does MATLAB have a plus equals function? So you have to, so you can have I plus equals 1 instead of I.
Oh, I don't know. Maybe. It probably does. I just always do it this way. So remember, MATLAB always reads from, it starts at the equal sign, it executes right of the equal sign, and then it places it in the variable on the left of the equal sign. So that can be a little confusing. So I equals 1, so it goes to this equal sign and it says 1 plus 1 equals 2, and then it replaces I with the value of 2. So it doesn't get confused about repeating that variable on the left and right hand side of the equation. Okay, what I want to show you now is a nested for loop, which I'm not going to type out because that takes too much time. So, do you guys remember MeshGrid? Do you love MeshGrid so much? So this is why MeshGrid is great, because this code that I'm about to copy in here right now is how you would do MeshGrid if you had to do it in loops. So remember that the purpose of MeshGrid is if you're trying to define a function z that varies, with respect to x and y, you need to get all of the combinations. So that's why it's called MeshGrid. So when x equals 1 and y equals 1, 2, 3, 4, 5, you need to get all of those. Then when x equals 2 and y equals 1, 2, 3, 4, 5, you need to get all of those. So in order to get all those combinations, MeshGrid does it for you. If you want to use a for loop to do the same thing, then you need to create one for loop that has your I index that goes through all your x's, and then you need to nest into it a second for loop that has all your j indexes. So what it will do is the for loop will start for I equals 1, and then for j equals 1, and it will define z for I equals 1, j equals 1. Then it will go for j equals 2, but I still is 1, and then it will define it for I equals 1, j equals 2. And then it's going to go for j equals 3, I equals 1. Do you get the pattern? And then it's going to go, when it finishes all the j's, it's going to go to the next I equals 2 and repeat the same thing. And so it's going to get all combinations of i's and j's or x's and y's. And it basically will do the same thing that like a MeshGrid would do to create that 2D data. So we are going to do nested for loops on occasion. Your lab 5 that you're going to be starting on, I'm so proud of this, just listen to this is amazing, requires an if statement, a for loop, and a while loop. I've never been able to come up with an assignment that has all 3 in one. I've always had to give 2 assignments on this lab. This one has it all. And this is a really fun assignment. It's basically a population code that you set a population to a grid, and then there's rules that if there's two neighbors that are populated, then they reproduce. If a cell has no neighbors, then it dies. And then there's one other condition, like where they both kill each other or something like that. You'll see the rules. But you're going to need to use logic to interpret that into if statements and for loops. So I guess you guys are done. So see you later.